Ganjil, kelas Pendidikan Kimia B angkatan 2022 akan melaksanakan praktikum Fisika Dasar mengenai materi Fluida Statis. Sebelumnya, izinkan kami untuk memperkenalkan diri terlebih dahulu, dimulai dari sebelah kanan saya.
Saya Islamia.
Saya Fatikhah Rahmadani.
Saya Novi Widiyanti.
Saya Annisa Alia.
Saya Adinda Maharani.
Baiklah, mari kita mulai praktikumnya.
Nature fears of empty space when he claimed that a true vacuum, a space devoid of matter, could not exist because the surrounding matter would immediately fill it. Fortunately, he turned out to be wrong. A vacuum is a key component of the barometer, an instrument for measuring air pressure. And because air pressure correlates to temperature, and rapid shifts in it can contribute to hurricanes, tornadoes, and other extreme weather events, a barometer is one of the most essential tools for weather forecasters and scientists alike. How does a barometer work, and how was it invented? Well, it took a while. Because the theory of Aristotle and other ancient philosophers regarding the impossibility of a vacuum seemed to hold true in everyday life, few seriously thought to question it for nearly 2,000 years, until necessity raised the issue. In the early 17th century, Italian miners faced a serious problem when they found that their pumps could not raise water more than 10.3 meters high. Some scientists of the time, including one Galileo Galilei, proposed that sucking air out of the pipe was what made water rise to replace the void, but that its force was limited and could lift no more than 10.3 meters of water. However, the idea of a vacuum existing at all was still considered controversial, and the excitement over Galileo's unorthodox theory led Gasparo Berti to conduct a simple but brilliant experiment to demonstrate that it was possible. A long tube was filled with water and placed standing in a shallow pool with both ends plugged. The bottom end of the tube was then opened and water poured out into the basin until the level of the water remaining in the tube was 10.3 meters. With a gap remaining at the top and no air having entered the tube, Berti had succeeded in directly creating a stable vacuum. But even though the possibility of a vacuum had been demonstrated, not everyone was satisfied with Galileo's idea that this empty void was exerting some mysterious yet finite force on the water. Evangelista Torricelli, Galileo's young pupil and friend, decided to look at the problem from a different angle. Instead of focusing on the empty space inside the tube, he asked himself what else could be influencing the water. Because the only thing in contact with the water was the air surrounding the pool, he believed the pressure from this air could be the only thing preventing the water level in the tube from dropping further. He realized that the experiment was not only a tool to create a vacuum, but operated as a balance between the atmospheric pressure on the water outside the tube and the pressure from the water column inside the tube. The water level in the tube decreases until the two pressures are equal, which just happens to be when the water is at 10.3 meters. This idea was not easily accepted, as Galileo and others had traditionally thought that atmospheric air has no weight and exerts no pressure. Torricelli decided to repeat Berti's experiment with mercury instead of water. Because mercury was denser, it fell farther than the water, and the mercury column stood only about 76 centimeters tall. Not only did this allow Torricelli to make the instrument much more compact, it supported his idea that weight was the deciding factor. A variation on the experiment used two tubes, with one having a large bubble at the top. If Galileo's interpretation had been correct, the bigger vacuum in the second tube should have exerted more suction and lifted the mercury higher, but the level in both tubes was the same. The ultimate support for Torricelli's theory came via Blaise Pascal, who had such a mercury tube taken up a mountain and showed that the mercury level dropped as the atmospheric pressure decreased with altitude. Mercury barometers based on Torricelli's original model remained one of the most common ways to measure atmospheric pressure until 2007, when restrictions on the use of mercury due to its toxicity led to them no longer being produced in Europe. Nevertheless, Torricelli's invention, born of the willingness to question long-accepted dogmas about vacuums and the weight of air, is an outstanding example of how thinking outside of the box, or the tube, can have a heavy impact.
Sekian dan terima kasih.
Wassalamualaikum warahmatullahi wabarakatuh.
Dadah.